Hey everybody, so this is the solution video for Worksheet 5.2. We're going to be talking about inverse functions and what it means for a function to be one-to-one. Okay, so we got a few examples to do here. Let's start with number one. We've got a nice linear function, 6x minus 2, and we'd like to determine first that f is one-to-one, because we know that in order to have an inverse, a function first needs to be shown that it's a one-to-one function. So there are a couple different ways that we could do this. One way that we could do this is that we could show that the graph of f passes the horizontal line test. So that's one way. And as we go through this, you might want to kind of compare how we found things were functions in chapter 1 and compared to how we're going to be determining that things are one-to-one functions, because a lot of the tests are similar but just a little bit off. So that's one we could show. And again, if something passes the horizontal line test, it just means that we can graph any horizontal line and it's not going to hit the curve in more than one spot. So with that in mind, let's use this first method of determining that something is one-to-one to check this curve f. So we'll go ahead and go over here and we'll sketch a curve of this linear function. So we know that it's got a y-intercept of -2 and it's got a slope of 6, so we might see something that would look like this. So this may be y is equal to 6x minus 2. And again, what we'd want to check with the horizontal line test is that for any horizontal line that we draw anywhere on the curve, it's only going to hit it more. It won't hit it any more than just once, which in this case it does not. We're only going to hit this line once because it is a straight line. So we can conclude by looking at this that this passes and I'm just going to abbreviate it as horizontal line test, HLT. So f is one-to-one. One. And again, I'm probably going to abbreviate one-to-one for the rest of this video as just 1-1 for one-to-one. So that's a pretty easy way, as long as the graph isn't too complicated, to show that we have a one-to-one function. The other way, so this is a second method of showing that something is one-to-one, is that recall. I'm going to write this in a different color. So recall that f is a function. So how we defined a function if each x goes to exactly 1y. And you remember the way that we did this on in chapter 1 is that we went ahead and we took our equation, we solved for y, and we made sure that no matter what x we put in there, it was only going to go to one y value. We have a very similar way of dealing with one-to-one. So the way that we'll talk about it in this case is that it's going to be one-to-one if we can show that each y is matched to no more than 1x. And the way that we could do this is we could solve y equals f of x for x. And then we can see that, well, is it the case that each one of these y's is only going to go to 1x? We're going to actually do this in part B as part of our process of finding the inverse. So we'll do a little bit more on this later. But this is another way that we can show this, and we'll talk about that in a second. Okay, so we know that this one is one-to-one using the horizontal line test. So let's go ahead and we'll find the inverse function. So this is the process that I might suggest for finding the inverse. It might be a little bit different from what you talked about in class or in the text, but there are lots of different ways, and they all basically do the same thing. But what we're going to do here is we're going to do it in 4 steps. So step 1, we're going to set y equal to f of x. So in our case, what this means is that we're going to say y is equal to 6x minus 2. Okay, so for step 2, what we're going to want to do is we're going to want to solve for x. So this kind of plays into this idea of determining whether or not it's one-to-one. So we're going to see what in a second what happens here. So if we solve this equation for x, first we're going to add 2 to both sides. So we have y plus 2 is equal to 6x. Then we're going to go ahead and divide both sides by 6. So we get y plus 2 divided by 6 is equal to x. And this tells us that x is going to have to be equal to y over 6 plus, we can simplify that as 1/3. So here's a good opportunity where we could answer the question from part A. We could say, well, let's look at this right here. Now that we've actually gone ahead and we've solved this function for x, we could ask ourselves, well, does each y go to no more than 1x? Sort of the opposite of the question we asked for a function. And we can see here that no matter what y we choose to put in here, it's only going to go to one x value. We could plug in y equals 10, 100, a million, it doesn't matter. It's only going to go to one specified x value. So we can say yes to this. And again, this would imply that f is a one-to-one function. So just sort of a follow-up for this part up here. Okay, so let's get back to the process of finding the inverse. So step 3, after we've solved for x, what we're going to do is we're going to go ahead and we're going to swap the x and y. So anywhere that there's an x, we put a y. Anywhere that there was a y, we put an x. And that'll get us on our way to finding the inverse function. So here we'll say that this is y is equal to x over 6 plus 1/3. Now the reason we're doing this is because our inverse function needs to be a function of x. So that's why we're making this change here. And then lastly, we can just go ahead and let y equal f inverse of x. And if we do that, we get our inverse function, which is f inverse of x is equal to x over 6 plus 1/3. So with those 4 steps, that'll get us to where we need to go. And along the way, we've actually shown that our function was one-to-one. Okay, so let's we're going to do this a few more times. So let's go ahead and start off with number 2 next. So we've got another function. First, we want to show that it's one-to-one. Okay, well, we know we're going to hit the second way of showing it in part B. So let's just go ahead and start off by trying to prove that it passes the horizontal line test. So we're going to graph f, and if we do, this is a rational function from chapter 4, so we know what these look like. This is a pretty basic one. We've got a vertical asymptote at 2, and we've got a horizontal asymptote along the x-axis, and we've got a y-intercept at -1/2. So if we were to graph this, we would see that the curve would look something like this. Vertical asymptote, horizontal asymptote, and we've got a curve that looks like this. So does this pass the horizontal line test? Yes. So this passes the horizontal line test because we can draw any horizontal line we want, and we are never going to hit this curve in more than one spot. So because it passes the horizontal line test, this implies that f is one-to-one. Okay, so now we can go ahead and we can move on to part B. So we want to find the inverse function. So let's go ahead and we'll go through the same 4 steps that we did in the last one. So step 1, what we did is we let the function, we set it equal to y. So we've got y is equal to 1 over x minus 2. And then in step 2, we're going to go ahead and we're going to solve this for x. You may have a couple different ways that you approach this. There's definitely no one only way to solve this equation for x, but this is the way that I'd probably do it. I'm going to go ahead and I'm going to multiply both sides by x minus 2. So if I multiply both sides by x minus 2, this is what we're going to see happen. So we have x minus 2 times y is equal to 1 over x minus 2 times x minus 2. So these are going to cancel out, and what we're left with is just x minus 2 times y is equal to 1. Now we're trying to isolate x here. Resist the urge to distribute the y, because we want to get the y to the other side. We don't have to worry about it again. So I'm going to go ahead and I'm going to divide both sides by y. And if I do that, that's going to give me x minus 2 is equal to 1 over y. And then I'm just going to go ahead and I'm going to add 2 to both sides. So that's going to give me x is equal to 1 over y plus 2. Now you may have done it another way. You may want to find a common denominator, but if you did, you may have gotten an inverse, or the right side may have looked more like this: 1 plus 2y divided by y. These are both the same thing, so either one of these would be appropriate solutions here. Okay, so now we're going to move on to step 3. Step 3 says let's swap the x and the y. So if we do that, I'm going to have y is equal to 1 over x plus 2. And in step 4, we just make this our inverse function. So f inverse of x is equal to 1 over x plus 2. And again, you may have gotten, or f inverse of x is equal to 1 plus 2x over x. Either one will work. Okay, so that's our inverse function. And again, we could go back to show the one-to-one to this step, that no matter what we choose for y, it's only going to go to 1x in this case. Okay, so that's why we know that it's one-to-one here. All right, so now with step 3, we're going to be pros at this. So we'll start off with the horizontal line test. So if we graph this, we know that this is the x cubed function shifted up 5 units. So this is 5 right here. And if we were to graph this, the cubic function looks something like this. Again, we look at this, it passes the horizontal line test. So passes the horizontal line test. So we can conclude that f is a one-to-one function. So we can move on and find an inverse. Okay, so to find the inverse, we go through each of these steps. So step 1, we let y equal x cubed plus 5. And now we go on to step 2. And in step 2, we want to solve this for x. So our first step is let's go ahead and subtract 5 from both sides. So we get y minus 5 is equal to x cubed. Now we could go ahead and we could take the cube root of both sides. So we take the cube root of y minus 5 is equal to the cube root of x, which is just x. So we get that x is equal to the cube root of x minus 5. Again, here we check. No matter what y we plug in, we're only going to get one x value. It's only going to get associated to one specific x. So we know that it's one-to-one, which we kind of already knew from part A. Part 3, or step 3 of this, we're going to go ahead and we're going to swap the x and the y. So we're going to have y is equal to the cube root of x minus 5. And then lastly, step 4, almost trivial, but a good conclusion, that our inverse function f of x is equal to the cube root of x minus 5. Okay, so that's how we would do that one. And then somewhat similar to that last one, we're going to go ahead and we're going to try this fourth problem we've been given. So we want to go ahead and first show that f of x is 1 to 1. Let's graph this. So this is the cube root function, and the transformation we see here is it's been shifted to the right 2 units. So if we know what our graph of our cube root function is, it's going to look like this. By the way, this is a section where it really pays off to know how to graph functions, the basic ones, and infer transformations, because we're able to very easily visualize the graphs and see that something like this would in fact pass the horizontal line test. So passes horizontal line test. We know that f is a 1-to-1 function, so we can move on to part B. Step 1, y is equal to the cube root of x minus 2. This is going to kind of seem like we're doing the last one backwards, which we pretty much are. And step 2, we solve for x. So first thing we're going to do is we're going to cube both sides, which is going to give us y cubed is equal to x minus 2. If we add 2 to both sides, we have now isolated x. So that gives us that x is equal to y cubed plus 2. Step 3, we'll go ahead and swap the x and the y. So y is equal to x cubed plus 2. And lastly, in step 4, we have now identified our inverse function, which is a function of x cubed plus 2. Okay, so those are some examples of how to find inverse functions and show that functions are 1-to-1, and I will see you all in the next video.